Hello everyone. In this video we are going to see operations of doubly linked list. We are going to use C language for implementing doubly linked list. The operations we are going to implement in doubly linked list are here. So first of all, we will create a doubly linked list having a certain number of nodes. Then we will do a traverse function, or you can say operation. Then we'll do a search based on a value. Then we can see about insert a new node at various positions. Then we'll be seeing deleting a node from the doubly linked list again from various positions. So first of all, we have to define a node for the doubly linked list. Okay, so if you take a doubly linked list, it will be like this. So if a node having some compartments, okay, so if the doubly linked list contains kind of 4 nodes, each node will have 3 compartments. Let's go with a certain data, which we can say it's an integer, but it can be any other data type also. So this data, for our example, we are going to take integer, and there is going to be a address here, and there is going to be one more address here. What these addresses will point to. The address stored here will point to the next node. The address stored here will point to the previous node. Imagine we have 1000 as a starting address, 1500 as starting address for this, 2300 as a starting address for this node, say 4100 as a starting address. So this has 3 compartments. So here we will have 1500 stored. That means it will point to the second node. So in this compartment here we will have 2300 stored here. In this next compartment we have 4100 stored here. The previous compartment will have null. So first one has null. This one will have this 1000 stored here in the previous compartment. So this one will have 1500 stored here, which is address of the second node. Then the last node will be having 2300 will be stored here, and the next will be null. So this is a basic storage types. So we have to design a node like this, right? So first node you will keep a pointer. Okay, this pointer is called head pointer. The head pointer will store the address, say 1000, and you'll have one pointer called tail pointer. The tail pointer stores the last node's address. Okay, see, 4100 is the last node's address. The first node's address is 1000. So we'll be storing head and the tail node's address. So if you have a doubly linked list, then you can say it has information about head and information about the tail, nothing else. Sometimes we will keep one more additional information, which is nothing but a total number of nodes present in the doubly linked list. So in our case, we will, apart from tail and head, we say total node count. We can keep total node count. So in this case it is 4. We have 4 nodes here. Okay, so to achieve this kind of connection, we will first create a doubly linked list having at least some 6 nodes. That's our first step. So first we'll start with putting value 10, 20, 30 and 40, like this, 50, 60. So first we will try to create a linked list having 6 nodes. Okay, let me take you through the code part of this. So we'll start with basic header files. So here we need to as I told you, we need to install, we need to declare the type of the node. Okay, so we are going to do struct node. So it has data, as I told you. So data, we're going to say it is a data integer, and we're going to pointer called previous pointer, and we're going to have a pointer called next pointer. Okay, so here this address, we're going to say it is a previous address. This is going to be a next. So the name of this compartment is next compartment. The name of this compartment is previous compartment. So the data is of type integer. But what is this address points to? The type of data the address points to is again a node. So it's a pointer, we say here, but what's the type it is pointing to? It is again pointing to a struct node. So this is a way you have to declare a node for a doubly linked list. Okay, so apart from that, I told you we need to have a head and tail. Okay, so we'll initialize some variables with the name head. We'll put as a null, and there is a tail node, and that also you start with this null. And we'll have a integer. As I mentioned, we need to keep a total node count. So this is additional information, total node count. Okay, so initially it is 0 number of nodes. So these are all the global variables we have initialized for our doubly linked list. So we'll start with creating. So we'll write our main function. We'll write separate functions for each one. So first we'll create one, as I mentioned, we'll create a 6 node doubly linked list. Doubly linked list having data 10, 20 to up to 60. Okay, each node containing data. The data is starting from 10, and the last node contains 60, like this. So we will call this function from here. We'll say create DL doubly linked list. I'll call this one here. Or if you give what's the number, you will just pass the number. How many numbers you want to create? You can just say count. Here we can rename to total nodes. You just use count here. So if you pass what is the count, it will create a certain doubly linked list initially. Let us just say we are passing 6. Okay. So first of all, we need to use malloc to create a variable for a new node. So malloc is a function. If it has for 100 bytes, it will allocate 100 bytes and returns the starting address back to us. So we don't know how much bytes this node structure will take, because there will be some padding effect will be there. So we'll use size of operator, and we'll give the data type struct node. So what it returns, it returns the starting address of the memory allocated, but usually it is of void type. So the starting address we are typecasting to struct node star. So this one we are storing it is in a variable called nn. So that we will declare here, which is a local variable. Nn we can say it is a new node. Okay. So what it has done, it has allocated struct node, size of struct node. So for one node size, usually say maybe this is 4 bytes, 4 bytes, 4 bytes, 12 bytes. Okay. But it will be in multiples of 8, so it might have allocated 16 bytes for this one case. So the 16 bytes starting address is usually a void star, so we are typecasting to struct node star, and it is pointed by NN. Okay, so first we'll put the data. NN of data is equal to, I'll start with 10, and NN of NN has next, and NN has for both we are just putting it as null initially. Okay, and this is our first node. Okay, so let us assume that we'll take this one there. Okay, so I'll just create this. So we have created, what we have done, we have created a new node. Okay, so imagine the new node starting at this is 1000, and we have variables. This variable is storing 1000 NN. Okay, so this NN is having 1000 now, and we already have a head which is declared as a global, and we have a tail pointer which is also declared as a global, but initially it is presented with null. So when you create a first node, head and tail both should point to the first node. So to make that happen, we just say head equal to tail equal to NN. So when we created this one NN, so here to the data part we store the value 10, and we put null here, we put null here as per up to this point. Then you put head and tail equal to NN, that means here we store 1000. Here also we store 1000. So head and tail points to the first node. So when we create the next node, okay, so at that time imagine we have just got 1300 as a starting address for this. So this NN will not be pointing to, should not be pointing to this one. It will be pointing to 1300. Okay, and we need this 1000 to be stored somewhere so that we can make connections. So this, in this place we have to store this value. Okay, this is the next compartment, this is the previous compartment. So in the next compartment we have to store the 1300. In this compartment we have to store 1000. So if we move, we don't have a 1000. So when we go on doing that one, we need to store the previous. So what we are going to do is, whenever we're going to move, we will move the two. So one is NN, and we'll create one thing called temp. So NN points to, say, nth node, means temp will point it to n minus 1th node. So it will go in pair. Temp goes here, NN goes here, temp will follow. Okay, so temp will follow NN. So wherever it goes, NN moves, temp will follow. Okay, so now if NN is in second node, temp should be pointing to the first node. So we need to take a backup of this one before NN has got changed to new node. Okay, so since we are going to put it in a loop, we are doing so temp equal to NN. I am taking a backup here, so we will do a declaration for temp. Initially temp is also null. It's better to put everything as null initially. Now head and tail points to NN. Now temp is pointing to NN. Next time NN will move on. Okay, so this one we're gonna put the whole thing again here. I'll put this whole thing in a loop. Say for example for j equal to 2, j less than or equal to how many nodes to create, we'll put here. Okay, then I plus plus. So this whole thing we're gonna put it here. Let me explain. So this is first time we have created this. Okay, first node created. In this loop we are going to create from second node to all the whatever the count we are getting from the function call. So instead of this 10, I'll put a j cross 10. So this next time it is 2 means 20 will be stored, and there is no need for this one. We have a head and tail and all initialized here. Temp is initialized to NN at this point. So here when we are doing this connection, when we create the second node, see, when we create the second node, what we have to do is we need to store at this point this 1000 value. Where it is stored, you just see nn of since we are creating by default you can put this next and null initially. After that you can change it. So nn of previous, okay, equal to or temp, okay, because temp is storing, if you see temp is storing this previous ones. Okay, so we store the temp. So in nn of previous compartment we have stored the 1000 here. That's done. Then what you have to do, the temp of next, in this compartment you have to store the nn value. So temp of next equal to nn. So what we have done, so in the first step here nn of previous equal to temp. So nn of previous means this compartment. This is a previous compartment. So in this compartment what are we going to copy? We're going to copy temp. So temp, we took a variable called temp. Temp is storing 1000. So this 1000 is copied to this place. Yeah. Next, temp of next equal to nn. So temp is pointed at 1000. 1000's next area, it is actually pointed in null. Here what are we copying? Nn. What nn is stored? Nn is stored 1300. So we stored 1300 here. So it is pointing to this one and this is pointing to this one. So we made a connection like this. So this is null. Okay. So when you create a new node, the next point will be null. So what we can do, we can remove this one because next is indigo. We're gonna change it. So next, the previous will be changed. Only the next part will be null for the new node. Okay. So for the newly created node, next part is null. This part is null. So finally, the newly created nodes will become tail. So when we come out of this loop, if you imagine this one, we are doing this logic for 6 times, of 2 to 6. That means 5 times it is running. Outside we have created one node here. So the head we are not changing. Tail we have to change once the loop is finished. Okay. So once you do the connection in these 2 lines, we make temp to point to the nn. Okay, so temp to the point nn means instead of 1000 it will be having 1300. Why? Because when the loop continues, we're going to create a new node, so nn's data will be different. So imagine it is 1700. So nn will be 1700. Now nn points to this one and the temp points to 1300. So it follows. So that will make a connection from temp to this and nn to this. So this continues. Okay. So once you come out of the loop by creating this, you just have to put nn tail equal to nn. So finally, when we created 6 nodes, let's assume that we are creating 4th node, then 5th node, then 6th node. So there will be 2-way connections between these, right? So when this is nn, this will be temp. Okay, so you do the connection and this next will be null here. So this nn, imagine if it is 1400. So this value should be stored in tail. Okay, so 2400. So this is stored in temp. So head points to 1000, tail points to 2400. So when I start from head, I can reach tail. When I start from tail, I can reach head. So it's a bidirectional movement. So we have created what this number of nodes the main is asking for. It asks for 6 nodes. We created 6, so it is having 10 here, then 20, 30, 40, 50, 60. These many nodes are created. Okay. So let us just verify this by calling a traverse function. So we'll write a traverse function. Traverse function, how to traverse. Let's just see. You start from head, then we will go all the way to tail. Okay, so head is pointed 1000. So imagine I'll just change it to So we have a head data which is say 1000. We have tail pointer variable and it is pointing to 2400. Okay, so we have many nodes like this internally that are connected to each other. So this is 2400, which is the tail node. This is 1000, this is the first node. So first we'll start with a variable, declaring a variable called temp, and we'll take this one and put it in the temp. So temp points to the first node. Then we'll print the data here. After printing the data here, we will make the temp point to this node. So first temp point to 1000. Okay, but how do you get to the address of this node? It is stored in this location. Okay, so we will be, whatever the value here, we will copy it over here once it is printed. Okay, so that's the idea. So first we will just say struct node star temp equal to head. Okay, so global variable head. So we store this one. Then we have to print temp of data. Let's say print of So after printing this, what you have to do is just have to store what is present here. Okay, so in the next compartment. So is the next compartment, this is the previous compartment. So the next compartment, what is stored here, that should be copied to this temp. How will we get the third compartment? It's a structure, so using arrow operator we have to get. So temp equal to temp of next. So this is having the higher precedence. Arrow has the higher precedence, so this will be solved first. So we'll get the second node's address from the third compartment, and then it is stored back in temp. Say for example, if the starting address is 2100 here, imagine, actually 2100 will be here. This value is copied here. So temp of next is this third compartment containing 2100. That value is moved here. So instead of this one, it is 2100. So now temp points to this one. Okay, so we'll print the data here. So this goes in a loop. Okay, so I'll put a loop. These two logic of printing and moving is happening in the loop. Okay, when do we have to stop the loop? That we have to write a condition over here. So temp goes here and temp goes here. When the temp finally is here, imagine, and the temp is finally here. Okay, so this is the tail node. Okay, so the tail node contains 2400. So when it reaches, this is containing, if it is 6 means 3, 4, 5, 60. Actually 60 is our data here. So after there is a null. The tail node's next is null. The same way head's previous is null. So this is null, this is null. So when the temp is here, it will be printing the data. That is nothing but 60. After printing the data, what will get? Temp of next. What is temp of next? Null. So null is stored in temp. So that means this temp will contain null. So when this condition reaches, that means you don't need to go further. Okay, so what you have to do, so it's temp not equal to null. Temp not equal to null, you need to go inside. Okay, otherwise you can just put temp alone, it will work. Not equal to null is not needed. You can just go like this. If it is null, it will be coming out, or you can say not equal to null. Both will work. So we'll verify this by running the program. So here we had one more thing. We have a total number of nodes, 0 initially. So here what we are doing, we are just doing a count, just create DLL. So once it is created, we'll just put that one. So total nodes in the DLL is initially, when we call the count, is actually whatever the count is. So the total nodes is, if it is passed is 6, the total nodes will be 6 here. Okay, so we call this one, let us run this code. Okay, so we got 10, 20, 30, 40, 50, 60 as a okay, so we'll just put some space over here, and so you got this, right? So we have um, data printed for 6 nodes. So this is how we have to create a simple doubly linked list. Now let's get into code for inserting nodes. Okay, so before that, let's see how much the value this total nodes is. It's all will be correct only because we are just assigning whatever we are passing here. So 6 is created. So now we'll write a function called insert. Okay, so the operation is insert node, or you can say insert node based on a position. Okay, so based on the position, so first we'll get a value, what value you want to insert, then we'll just get a position, what position you want to insert the node into, right? So this returns void, like this will do. So what happens here, if you have a linked list created for doubly, so if we have like this, for example, I can create a new node, okay, and I can make it as a first node. So this is actually head, okay, head will point here and the tail points here. So first the thing is, you can insert a node as a head node, or you can insert a node as a last node, okay, or you can insert a node anywhere in between. So if the position is 1, so here if you see total node count is 5. Okay, we have 5. This is new node created. Imagine this is new node. So if you are putting in position 1, this is position 1. It's a head node. If you make the position as 6, okay, that means it is 5 plus 1. That means it's a tail node. So if position is 1, it's inserted as a head node. If position is 6, that means count plus 1. So if it is count plus 1, total count plus 1, it's a tail node insertion. Okay. So first we'll write code for this, then we can write for insert in the middle area. Because this is somewhat very easy, because we just need to change the head pointer. So if it is inserted as a head node, this will be the new head. Okay, so we'll start by inserting it in position 1. So now if pos equal to 1, that means we are inserting node as a head node. Okay, so first we'll copy this code where we create node. Okay, so again we need to declare step node star nn, which is initially put up as null. We have created, and the data which is going inside this is equal to value. So we are passing a value. What are the value we are putting it here? Then we will initialize it to next equal to, what's the next of this one? Let's understand this. So now we have created a node. We put the value. Okay, imagine the value is say 555. We are passing 555. We'll write a call also. So insert, we are passing say 555. We're calling, and then we're just saying position 1. So where the 555 is written, the 555 is written in the data part, and we have next part. Now we have next part. We have previous part. So in the previous part, it will be null. Okay, and the next part, what will be there? The current head is there. No? So the current head, whatever it is pointing is, imagine if the starting head is 1000 for this 1000 should be stored here. Okay. So where is this 1000? Who knows this 1000? Head. There is a variable called head. That pointer variable contains address 1000. So we just have to copy the head variable's value into this third compartment. So here when we do next is equal to head. Okay. So by doing this we made this link established. So this link is established. Now we have to, there is a head here which is 1000. Its previous is null. But once this is added as a head node, its previous will not be null. They should be pointing to the address of this one. If they imagine the address is 750, starting address for new node, this 750 should be stored here. Okay. So that link we have to do. So that is head of previous equal to NN. So NN is 750, that is stored over there. Now we made a two-way link. So this points here now. Okay. Now after this, who is a new head? This 750. So instead of 1000, we have to store 750 in the head variable, which is a global variable. So once after this, we just say head equal to NN. So by doing this, we just change the head. Okay. So we'll verify the score by calling traverse again. So we need to see that we'll give a new line printf after this printing. Okay. So we'll compile this. You see here we have previously and we put a 555 as a first node. So we have all the other nodes here. Okay. So this is fine done. Head is changed. Okay. Now imagine if we insert a node as a tail node. Okay. So we have many nodes already. Like this we have. So it is count. Total count is 1, 2, 3, 4, 5. We have 5. Okay. The new node will be the 6th node. Okay. So if it is total count plus 1, new node will be the last node we are going to insert. So this is the head currently and this is the tail. So when you insert a new node as a last node, the tail will be changed because the new node will be a tail. So before that we have to make a connections, two-way connections. So this one's next is null, but this one's previous we have to store this one's address. In this place we have to store this one's address. Okay. So currently the tail points to this one. Tail of next equal to new node. So first we'll make this as a common one because we're going to create anyhow. So this is common. We will put it over here. And data also we can put it as a common one. Okay. So we just put a else if pause equal to what? How do you know that it's going to be last node? If the total number of nodes whatever it is, and if it is plus 1, that means it's our last node. If the total number is 5 here, 1, 2, 3, 4, 5. So if you are saying 6, that means it's going to be last node. If you say 5, that means it's going to be 5th node. It's not a tail node. So it has to be 6th. So that's why we put a plus 1. So in this case, what you do? Current tails next is new node. Okay. So current tail is next. You just say is equal to NN. Now we made this connection. Now this connection is made. Now we have to make this connection. What is this? New nodes previous equal to tail. New nodes previous compartment. What are we storing? Whatever is stored in tail. Whatever is stored in tail is copied in the first compartment of the new node. So we made that also. And then new nodes next is equal to null. You see here. This is null. So we have done this. We have done this one second. We made this as a third one. So now after that there is a fourth one. This should be the new tail. Okay. So we should not have this as a tail. It becomes a penultimate one. So who is going to be the tail? Now new tail is going to be NN. Made this one. Now let's see. Already it has 6 nodes. We will make it to a 7th node. Let us compile and see. See 10 to 16 and 555 is put up as a last node here. Okay. So this way we can insert in a position like insert node as tail node. Okay. So if it is else, or these are all in between node insertions. In between insertions. So here we need to do some traversals. Okay, so first we'll understand what is that in between area, what we have to do for that. Say for example we have certain 6 nodes combination as we had in this place. So in our example also we had 6 nodes. So 1, 2, 3, 4, 5, 6. We have 6 nodes doubly linked list. Okay, so this is head node pointed here, and the tail pointer points to this node. Okay. Now imagine this is node 1, node 2, node 3, 4, 5, 6. Total you have 6 nodes. Imagine I want to insert node at say 5th position. Okay, I want to insert a node at 5th position. That means I will create a new node. Okay, so this node will be the 5th node. Imagine after the insertion. That means who will be the 5th node? The current 5th node will become a 6th node. The new node becomes the 5th node. So new node is the 5th node. That means what will happen to the 5th node? It will become 6th node. Okay. So if I want to insert a node at 5th position, we need to go to the 4th position. Okay, we need to traverse up to the 4th position. Okay, or we can go to 5th position also, but in case of singly linked list and all, we need to, if you are working on ith node, if I is 5, then you have to go to I minus 1. So it's better you can catch other nodes from that point onwards. So you need to get to a 4th node if you want to work on 5th node. If you want to put a new node as a 5th node, or if you want to delete a 5th node, you have to go to 4th node. Okay, so if you write one utility function, that function will return a node address back to us if we give the position. So if I give 4, it will return address of 4. Okay, so we'll write that one so that we can reuse it in other places. So I'm going to write a function called get ith node. Okay, so here we are giving let us imagine that I. Okay, so what it returns the address. What is the address? Struct node star. So get ith node. So whatever the number you give, that node's address. So if the position, if the I is 5, that means if position is 5, it will give the 5th node's address. Okay, so what's happening here? Let's or you can just say pause. So if you are giving position, it will return that ith node, means that position is ith node. So that's why we can keep I, because we are giving name as I, so it's I you are entering. So if you are asking for 5 here, it will give the 5th nodes. If you are asking for 10th nodes address, it will give. Okay, so for doing this, we need to start traversal. Okay, so struct node start temp, we have a head. Okay, so usually we start with head. Okay, and imagine position is what is the position for this one? It's 1. Okay, so we will have a int pos position equal to 1. Let us just assume that currently position is 1. So let's go with the for loop. The for loop, what's it gonna do? It's gonna put temp equal to temp of next. Because we are going to traverse and we are going to get it. What we are doing, initially we are in position 1. So position is 1. Okay. So this is push 1. Temp is head. Okay, it's pointing here. If you are asking for I as 1, you have to return. Okay. So what you have to do, the current position is less than or equal to I. Okay. So imagine if you're asking for a first node, that means it is I is 1 and the position is 1, it has to return. Okay, that means we will not be giving this equal to. Okay, so portion is 1 initially, so we will just return temp here. Okay, so temp, so first initially we are pointing temp to head. Okay, so if you are asking for a first position, it just says what is position value 1. Is 1 less than 1? No. So that means it fails here, it won't go inside, it returns temp. Okay, so if you are asking for a imagine fourth node, you are asking for a fourth node. If this is I, so that means here I is 4. So this is 4, position is 1. Okay, so how many jumps it has to do? 1. Then I will pause. We have to do pause plus plus. So pause will become 2, then 3. So if I equal to 4, so pause is 1 initially, then 2, then 3. 3 times a jump will happen. So first jump will take here, second jump will take here, third jump will take here. So if you're asking for position is I is 4, your starting position from 1. Then pause goes here, then pause is 2, 3, then pause is 4. So how many jumps? 1 jump, second jump, third jump. 3 jumps you are doing to reach here. So this is correct condition. So you have to make sure that condition is proper so that you reach correct things. So you should be careful in putting less than or less than or equal to whatever it is relevant to that point. So initially is push 1. We just so you can put the pause 1 here also, inside this also. So it returns temp. So now in this case, for example, since we are asking 4, if we ask 4, it has to return this one's address. We can verify by printing it. Okay, so we just say printf %d temp of data. So what we can do, we will call this function. We won't call these drivers. We just created, and then we will call this get ith node. Well, that is working fine. I'm asking for a fourth node. Fourth node data is actually 40. It's actually 40 here. So it is going here. It has to show 40 to us. 40. Right, so it's correct. So when we ask for 1 initially, the boundaries will check. The first node, it has to give us 10. Okay, so it seems quite correct. So we have a function return, utility function, which will get the address of the node. If you pass whatever ith node, it will return the address back to us. So remove this printing. So this is a utility function. We will use it here. So what I've told you, we are doing insertions in between the head and the tail in the linked list. So for example, we were somewhere here. Imagine we want to insert it fifth question. Let us assume that, and you need to go to fourth node. Okay. So this node you need a pointer. Then we will work on this. So currently it is device like this. So you have this one pointing this, you have the previous pointing this, and you have this next value pointing this, and you have the value which is nothing but the address of this node. Yeah. We need to insert a new node here. Okay. this new nodes data, we will say 555 we are putting. Okay, so initially we will make it as a null. That's the best habit. So we'll create it. Okay, data is put up, and the best way is to always next equal to nn of equal to null. This we have already created. Now new node is created. What I told you, we have to insert at fifth position. Okay, fifth position we are inserting, and the value is 555. So we need to go to fourth position. Fourth position we need a temp. Okay, we'll make we'll call of this. Okay, we'll call this one get ith node. Okay, so it is pass -1. So if position is fifth node, we are just calling get the fourth node's address. That we will store it in temp. Okay, so this temp we can declare here itself as a local variable. Start temp equal to null. So now in the temp we got the fourth node. Imagine we are passing fifth node. Okay, we need to insert a new node in the fifth position, so we need a pointer for the fourth position. So what we have done, 5 - 1 4. So we got the pointer. Temp points to the fourth node. Okay, so now the temp points to the fourth node. Now it's very simple from here. So in this place, what you have to store, what is stored here, this should be copied here. Okay, this value should be copied. You copy this. That means you will make a pointer to this one. So if we do that, it will directly point to this one. Okay, sorry, that's delete. Okay, we are inserting, right? So we will change the logic. Okay, now currently it's here like this. Now what we have to do, this is going to be the fifth node. Okay, so what this should point to, so current fifth node, it should, the next of the node should point to the current fifth node. Okay, and then the previous should point to the fourth node. Is it done now? So we will just make sure that these two are done. So if you are inserting new node as a fifth node, the current fifth node will become the sixth node. That means in the next compartment, we need to store the address of the fifth node. How do you get the address of the fifth node? Where it is stored here? It is stored in this place. That means temp of next. Okay. Temp of next equal to temp of next. The temp of next is stored in, so this is temp of next, this value. The temp of next, this value we are copying and we are storing it in this place. Okay, so which place? NN's next. So NN's next. Okay, so by doing that we have done this work. This is done first. Now we'll do this one second. That is NN of previous. In NN of previous compartment, what you have to do, you have to put the fourth node. The fourth node is pointed by temp. So now that's done. Okay, so two are done. So this is done, this is done. Now this is still existing. Okay, so what will happen? This previous, this is fifth node, it becoming a sixth node now. So who is the fifth node? This guy is the fifth node. So this one starting address is there now, which is pointed by NN. That should be copied here. So NN value should be copied in which compartment? The fifth node's compartment. So we have the fourth node. Okay, how do you get the fifth node? This one. So fourth node is still pointing to the fifth node. This address is there, right? So that address is previous. In this previous, we need to store the NN. So we have a temp. What is temp of next? Temp of next is fifth node. Okay, it is pointing to the fifth node. That address, this one. Okay, you see the compartment. So this one is what temp of next is. Okay, that means I am here. That's the address. This address. In this address, the compartment is previous. So it's a left to right solving. Previous equal to. So in this compartment, what are we putting? We need to put the address of NN so that we make this connection, the previous. So we will delete this one. So that means we put NN. Okay. Now this is done. Third one is done. This is done. Third one. Now this is removed. So we got a previous. And then the next. Okay. So the next in this place, what we have to store? We need to store the new nodes. Okay, so current temps next compartment should have the new node. So temps next compartment should have the new node. So this will make the job over. Okay. So first these two lines are working for new nodes, previous and next. And using this one, we are making connections altered. Okay, so we'll run this code and see. So we are putting it as a fifth node. Okay, let's see how it goes. Yeah, 10, 20, 30, 40. In the fifth node place, we got a 555. That's the data inserted, and then comes the sixth node and seventh node. Okay. Now, what you have to take care in mind is here. When we are inserting all these things, we are updating total nodes. We have to update that one. We didn't update that here. So finally, we put a plus plus in this place. So now we have seen the insertion in the first position, last position, and in between positions. And after that, we are updating the node count for insertion. This is one insertion, so we are just doing a plus plus node total nodes. Okay. Now we will see the delete, the last operation here. There are two types of deletions. We're going to see deletion based on position value, right? So first we'll just delete by position. So it gets pass value. So it won't return anything, or let's just put void. We are not doing any checking of positions. That they can change it if you are doing any validity of what you are deleting. If you are entering a position which is bigger than the total number of nodes, you can check all these. Now we will worry about the deletion of valid nodes only. Okay. So for example, we have inserted this 555 here. After that, our things will be 7 nodes. So instead of that, we'll keep only 6 nodes. Comment out, insert. So we'll call delete by position function. This function, if you put a 1 function, that means you are deleting the head node. Okay. Say if you are deleting the head node, let's assume that I have a node list and a doubly linked list. This is a head node, and this we have as a tail node. If I am deleting this head node, okay, what happens? This should become the head node. Okay, it or not. The next one. So where it is stored and all we need to find out. Okay, so let us assume that if you are having a head node, the head node's previous is null usually, and it has some value. Say for example, if it is having 1000, the second node starting address is 1000. That's what is stored here. Maybe this is 800 or something like that. So this is head. Okay, we need to make this as a head. Okay, if this becomes a head, it's previous. Now currently 800 is stored here. This should be made null. Okay. So what we have to do, we have to just change it. How to change this one? You see, for example, here we are deleting this. Okay. So head becomes this one. How to get this one? You need to just say head equal to head of next. That means head will point to start point here. Then we need to delete this one and all. So once head moves, we cannot um, uh, go back. Is it like that? Just think of this. If a get moves here, how can I go back to this? Okay, I can go back through this. It's 800. Okay, so I can just make the head move here. Then we can call free function for this 800. Then it will be deleted. Okay, so first one is move this one. Then call free. That's the second part. Then this will be deleted. What happened? Then you have to make this as a null. So 3 steps. Okay, this has been made as a null as a third step. So first move the head. So how to move the head? Head equal to head of next. So if pass equal to 1, what you have to do? Head equal to head of next. Okay, remove that. Then what you have to do? You have to call free. Okay, so free function head of previous. Okay, so that's 800. So currently this is a head. Okay, currently the second node became the head, but still its previous is having a value. That value means it's 800 starting address. So since you allocated using malloc, the corresponding memory size will be deleted when you call the free. After that, what you have to do? The current heads previous should be made null. So current heads previous should be made null. So after that, it should be gone. Now let's run this code. We are just calling by delete 5. So we have 6 nodes, 10, 20, 30. So 10 should not be coming if it is going well. There is something, we'll just see this. We have to call traverse function. We didn't call traverse. Okay. See this one? 10, 20, 30, 60 initially. After creation, we have traverse. After that, deletion traverse. We got a 10 deleted. Okay. Now last position delete. So that's a tail delete. What will happen if you are deleting by the tail? So if pass equal to what is that tail? Total nodes. If the total nodes is 6 node, means 6th node is the tail node. You are deleting the 6th node. Okay, that's the meaning. So now let's see how to delete the last node. Imagine you have a doubly structure like this. If the tail is here, the tail's next is usually null. When we delete the tail, who will become the tail? This guy will become the tail. So first, if you shift the tail to here, this is the first operation. Then what's the tail's next? So imagine this is 800, this is 900, this 800 is stored here, 900 is stored here. So first tail equal to tail of next. Now tail will point here. Tails next is 900, you call free, so this will be gone. That's the second step. Then what you have to do? This one you have to make it as a null. That's the third step. So that tails next is null. So it's very simple. So first we just make tail equal to tail of previous. So we move the tail. So now tail is pointing to this penultimate one. Now tail of next. This is a new tail. Tails next is 900. That means it was the previous tail's address. It is stored here. That has to be freed. We call free tail of next. Okay. After that, what you have to do? You have to make this 900 into null. That means tail of in the tail of next compartment. What you have to put? You have to put a null value here. So that's it. So we'll compile and see, but we didn't do the call. So what's the call we have to make? We have to make the call for total nodes. That means that's the last node we are doing. So delete the last node. That's the 6th node. total nodes is usually the sixth because we didn't insert anything. So 6 nodes we have inserted, the 6th node we are calling as the last node. Deletion. We got 60 removed. Okay. So what we have to update here is after deletion we need to call minus minus. Okay. So with this we can put else if else we are deleting in the in-between portion. Okay. What is this in-between portion? Let's see. This is deleting in between. This is deleting first node. Deleting head node. This is deleting last node. And any in-between nodes. In-between nodes. Okay, let's see how to delete in-between node. Now let's do the same way we have done for insertion. We need to go to say if you're say for example this is 4, 5, 6, 7, 8 or something like that. I want to delete say 5th node. That means you need to go to 4th node. So make a temp points to the 4th node. What's your objective? Objective is to delete the 5th node. So you get the address of 4th node. Okay. So we have compartments like this and all. First we'll get the address. So what to do? We have a position which is deletion of 5th node, which is in between node. Now get the 4th node. Okay. That how do you do? Start. Initially we put it as null. You call the function get ith node. So in the get ith node function, which node we want to get? If you are deleting 5th node, we need the 4th node's address. So pass -1 input. So now we got we need to delete 5th node. We got the 4th node's address. So what we have to do now? We need to store in this place certain things. Say for example, I'll give some values. If it is 1000, it is 1500. If it is 1700, like this. Where is 1700 is stored? 1700 is stored here. 1500 is stored here. 1000 is stored here. 1500 is stored here. Okay. So now in this place, 1500 should not be stored because it is going to go. What should be stored? 1700. Where is 1700? In this place. So whatever is present here should be copied here. Got it? So I put a single tick. So you copy what is present here into this one. How can I access the third compartment? The temp is pointing this one. Temp's next is this one. This next is this one. So this value should be copied here. Okay. So I can just say temp of next. So when you do temp of next, that means this value. That one's arrow operation doing next means this value. We got this value now. This is should be stored in this place. This place is nothing but temp of next. So this is R value actually. What we have done is R value. The L value is temp of next. Okay. So what we have done, we have copied this one. This is temp is 1000. Temp of next is 1500. That one's next is 1007. This value, this third compartment we got. This compartment is stored here. So we got this is temp of next. This 1700 is got here. This is copied and is pasted in this place. Third compartment of temp. That is this place. Now it is having 1700. So now it is pointing like this. Okay. Once you point like this, what happens, we are missing this. We need to delete this, right? I missed this 1500. Where it has gone? We don't know. Okay. So first, it's good to have one more pointer while moving this one. So we'll declare one more pointer called temp1 equal to null. So what we can do first initially before moving this, we can just say temp1 equal to temp of next. Okay, so that means now in this case what we are doing here, this is temp1, what we are storing here, temp1 of next. Temp1 of next is 1500. So we are using the value variable called temp1. Now temp1 is pointing to 1500. Okay, now we have two pointers, one pointing to fourth node, temp1 pointing to the fifth node. Now it is easy to do connections. Okay, so we can just say temp1 of next is nothing but this one. It is stored in this place. We can use temp1 instead of this thing. So we can just say temp1 of next. Okay, this way also you can do. So in temp1 of next is third compartment of temp1, that is 1700. This value is copied to temp of next, third compartment here. So now instead of this one we got 1700. Yes, this third compartment value is pointing to this 1700, but temp1 is still pointing to 1500. Okay, we have it. And then what we have to do, this one, okay, this 1700, which is temp1 next. This one, instead of 1500, it should be 1000. Okay, so we have to do this some work for this one. How can I get this 1700? It's stored here. So temp1 of next is equal to, what do you have to put? Temp1 of next is 1700 in this previous part. Okay, sorry, temp1 of next. Okay, so this play we have to store. Okay, temp1 of next is 1700 in this one's previous part. Okay, so in this one's previous part, that is previous compartment, temp1 of next is 1700 in this one's previous compartment. So in this compartment, what you have to store here, you have to store temp is 1000. Okay, you have to store temp. Okay, now we have done this. So what stored here, we replace this with 1000. So we have made this connection also. So now we just need to call free for temp1 because temp1 is still pointing to 1500. We call free temp1. That will be deleted. Okay. Hope you understood this. Let me compile this. But I think we didn't change the call. There are totally 6 nodes. We will call deletion of the 5th node. Okay. You see here 10, 20, 30, 40, 50. 50 is gone. We are printing 60. So we can change it to say 3rd node. See, 30 is gone. Right, 10, 20, then 40. 3rd node is gone. So we have verified the in between all these node deletions. Okay. So I can re-explain this one more time for this deletion of in between nodes. Okay. If you want to delete the 5th node, imagine. Right. This is 5th node. This is 4th node. So what we are doing, we are just calling a 5th node deletion. Let us understand this. 5th node deletion. So get the position of the 5 minus 1, 4th node. Okay, that we are pointing by temp. So that is a pointer variable which is pointing to the 4th node. Okay, so these are the compartments we have. So 5th node we want to delete. That's our objective, right? These are all in between areas. So let's I gave some address values, 1000, 1200, say 1450, like this. So 1200 is stored here, which is this address. 1450 is stored here. 1200 is stored in the previous part. 1000 is stored here. This is the scenario. Okay, so this is having value 40, this is having value 50, this is having value 60. This is sixth node. Okay, what you have to do, objective is what has to come here. Okay, what has to come here? Instead of 1200, it should be 1450. That means this one. Instead of this 1200, what should come? 1000. This is our objective, nothing else. Okay, so this is and then we have to call this free. So first we'll go here. Okay, we will have one more variable called temp1. That's what we have done here. Okay, so when you sorry, this is insertion. When you got the temp, you got a temp1 equal to temp1, temp of next. So temp of next is 1200, so that is stored in temp1. Now temp1 points to 1200. Now we got this. Now the interconnections. Temp1 of next. What is temp1 of next? 1450. This value copy and paste it in this place. How can I get to this place? Is temp of next. So temp of next, that is this compartment, is replaced with this value from temp1 of next, that is 1450. Now this is done. Now there is no more this connection. So it is connected to this one from. And the next one is temp1 of next. Temp1 of next. What is temp1 of next? 1450. That is this pointer. Inside this there is a previous compartment, that is this one. So in this place what are you going to store? Temp. That means this 1000 is copied here. Now this is removed. Now we got this pointing as a previous, this one pointing as a next. Okay, now finally call free of temp1, which is this we are actually wanted to delete. Okay, so this is a way the delete by position works. So as I mentioned, we're gonna use one more function called delete by value. Okay, so delete by value we will write here. So if you pass a value, it will delete that value. Okay, that's objective. Delete by value. Imagine that we are just passing delete by value. If you just say delete the value 50, okay, that means it searches for the value 50 in the nodes, the node containing the data 50, and it has to delete that node. Imagine in our case this fifth node contains that. Okay, so this is not a separate area. We need to just search that value and we need to get the position of the value, and we can call this function delete by position. That's it. So what we have to do, we have to search. So we'll write a function called search value. So it gets a value. Okay, so what it returns a position. So from this function we will call the search value. What's the value we are looking for? We will give to this one. So this function will return the position of the value you are searching. If it is present, it returns the index or a position, you can say first position or second position. If it is not present, okay, it is failure in searching means it will return -1. Okay, so based on that we can first do that. So once it returns the position, what you have to do, imagine we got the position. Okay, that position we have to call this delete by position. So once we got the position, we just say pause. I just say position. That position we are passing to that function. This is the objective. So if you are calling by delete by value, by giving certain value, first we will search for the value in this function. It will return the position back to us. Okay, then we will call the delete by position for that node. Okay, so this is a utility function. There is no separate delete for a value. The delete by value will use delete by position only. So first you search for the value, and if the value is present in a certain node, get the node's position. Okay, so for doing that we'll start with a job. So temp, we just say struct node, start temp, we'll just start with the head node. So here imagine that we got int push equal to 1. Okay, so current position is head is temp is pointed to head, that means it's a position 1. Okay, now let's see if temp of data is equal to what you are looking for. If that is the case, you just immediately what you have to do, return position. Okay, the pause. First initially the position is 1. If the data is found, you just return the position. Else what you have to do, pause temp equal to temp of next. Go to the next node, then pause plus. Okay, so let me just put a picture for this. So first we are in head part of the Doubly linked list. We have lots, and there's the head. Okay, and your temp is also pointing to the head. Okay, so at this point we have a pause equal to 1. So position equal to 1, temp is pointing to the head. Is it equal to our value? If you are looking for 50, imagine 1, 2, 3, 4, 5. So actually we had a 60 node, so 50 is here. Okay, this is having 10, this is having 20, this is having 30 as a data, this is having 40, this is having 50 and 60 we have. So initially it's position 1, temp is here. Not equal to value, we go here, temp equal to temp of next. So now temp will point here. And position we are updating to 2 because it's the second position. Okay, the loop has to go. So this whole thing should be put up in a loop. Okay, so I can just put the whole thing in a loop. Those if else conditions will put inside the loop. Okay, so what we are doing here, the loop we can write for infin. So temp of data pause like this, it goes. First of all, let it be 1. Okay, let us understand this. If it is not present, what to do for this. So here looking for 50. Okay, and then temp goes here, pause becomes 3. It is not equal to 50. Then temp goes here, then position becomes 4. Okay, then it is not equal to 50. Then temp goes here, position equal to 5. Okay, it goes here, temp of data. What is temp of data? 50. It's a match. So that means we are just returning position. What is position? 5. So the 5 is returned. Okay, so once the 5 is returned here, I got just to call delete by position. So 5 is present here, I just call 5. Okay, so this is the idea. But what if the data is not present? Imagine I am looking for 768. The first node is having 10, 20, 30, 40, 50, 60. There is no 768. So what is happening here? So now see, imagine the position is going on increasing. Okay, the position is going on increasing, and temp is also going on increasing. So when the temp reaches here, we will just say temp of data. Temp of data is 60. We will verify 60 is equal to 768. We are looking for 768. It's not equal. What will happen? It will come here. Temp equal to temp of next. So temp of next this is a tail node. Temp of next is null. So that means it will be a failure. So it's a null. So next time you should not go here. So I will change the thing to temp not equal to null. Or you can just keep temp alone when the temp is present. So when the temp is equal to null, what happens? It will come here. Otherwise, it would have returned from here. If you got a hit, it will have returned from here. If it never returns from here, it will be coming at this point. So in this point, you have to return -1, which I told you it's a failure condition. Okay. So if it is return a valid position, it is 1 or something like that, or I can just say 0 or something like that. So now I just put -1. If position is equal to -1, okay, now we can just say print of this is an else part. Okay, print of not present. Okay, so we will just say void returning. So if position is -1, so in this case, if it returns -1, that means value is not present. It will not go to delete by position. It just says not present. If it is not returning -1, if it is returning valid position, it will go here and delete the position. Okay, so let's try that. So we are just passing 50. How it works? Let's see. You see here, we have, and we are looking for 50, and 50 is gone. Deleted. Okay. Now when we are saying, say 768, as I mentioned, it's not present. It has to say not present. Not present. Okay, so it just prints the whole thing, and since we are calling Travis, okay, so it just says not present. Okay, so this is it, and there is no need to do minus here because in calling delete by value, we are still calling delete by position. So when you call delete by position, we need to decrement the total counts. So there is no need to explicitly decrement the value here. Okay, so the best practice here is hash include std lib.h, which is defining the malloc and free functions. Okay, those are all defined out there. So this is pretty much the functions as I mentioned. We have implemented various functions like creating a linked list and traversing and searching and inserting data at various positions of the node. Okay. Anyhow, I'll share this code in the description section. You can verify and you can try this code. I hope this helps you. So these are the various functions we have implemented. We'll see how far it's helpful for you, and then in the next video we'll see about the stacks and the queues implementation and its applications. Thank you.